Welcome to Sundar's lecture. This is lecture number 32, and in the last class we have seen this, right, difference between average value and root mean square value. We have taken an example with two different circles with two different radius, and we have found what is average value and what is RMS value, and where average value is applicable and where RMS value is applicable, right? So we have found that RMS value should be applied in the AC quantities to find the IRMS current values, or it may be VRMS values, right? So now we will take an example. Let us we take I is equal to, we know this one, right? So I is equal to Im sine theta, right? Theta or omega t. I have already told you it may be anything. See, this is the expression we are going to take today, and we try to find what is the RMS value. So we know, right? We know what is the RMS value. So RMS value should be equal to, see we will go here anyhow. See here, see RMS value should be equal to square the value of the average. See, this is actually the average value divided by this 2. That is nothing but the number of circles is here. It is 2. So we have divided it by 2. If we have 3 different circles, we would have divided it by 3, right? So for RMS value, you need to put it in the square root, and these are all the values that has to be squared. That has to be squared, and this term will be divided by the whole length, or it may be number of things we are taking, right? Here, if you are going for a, a curve or a waveform, then see, we need to put square root, that we know already. So it has to be square root. See, what is the average of a waveform? If it is an average of a waveform, then we need to take area under the curve, right? So here, area under the curve, that has to be squared. That has to be squared divided by total length. Total length, right? So this has to be the formula to find the RMS value, right? So what is the average area under the curve? So I try to write what is the area under the curve, right? We need to do that. So area under the curve. So how will you write that? Area under the curve, that should be equal to integration of, see, 0 to pi. I am taking 0 to pi. Why? Because you see, if this curve, we have this curve, right? This is the positive half cycle and this is the negative half cycle. Whenever we are taking average values, this is actually average, right? Instead of average, we are taking area under the curve. That is the formula for if we are taking the waveforms. See, if you take average for the both curves, it results in 0. So we never take average values from 0 to 2 pi because it results in 0. See, it is a positive half cycle. The same thing will come under the negative half cycle. So if you take average, then it becomes 0. So always you take average values from 0 to pi. So it is 0 to pi, and average under the curve, what is the value of this one? The value of this one will be Im sin theta. So what we need to do, that we need to square this term, right? So it will be Im square sin square theta. And what is this one? Total length. Total length I will write down here. So total length, that should be equal to, what is that? From 0 to pi we are taking, right? So length will be pi. Length will be pi. That's all. So now what we do, we try to simplify this expression so that we can easily find what is the RMS value, right? So we try to find this one. So we need to get the value. So what we can do, which is equal to, we will take this one, area, only area. So area, which is equal to, here im square is a common term. So bring it outside. So im square is the common term. Take it outside. And integration of sine square, okay, fine. Anyway. So 0 to pi is there. So sine square theta is what? 1 minus cos 2 theta divided by 2, right? That, and yes, okay, this will be d theta, right? So this will be d theta. So this term will be like this. Sine square theta can be written as 1 minus cos 2 theta divided by 2. So from this can be written as im square divided by 2. And if you are taking the integration for 1 minus cos 2 theta, for 1 it will be what? For 1 it will be theta, because constant value, minus sine 2 theta divided by 2, right? That is the integration. Then limits will be 0 to pi. That we know already, right? And if you substitute this pi and 0, this is a upper limit and this is the lower limit, instead of thetas, you substitute and you find, you will get im square divided by 2. Maybe I will do it by myself. Pi minus sine 2 pi divided by 2, that is one term, that is the upper limit. We have substituted the upper limit, and this will be the upper limit, minus the lower limit. If you substitute, instead of theta, that will be 0 minus sine 0 divided by 2. That is the lower limit, right? So you know, right, sine 2 pi will give you what? Sine 180 will give you what? It will be 0, and sine 0 is also 0. So these terms will become 0. This is 0, this is 0, this is 0. So finally you will get im square divided by 2 into pi. So that is the final value. So area, that is squared area. This is actually squared area. I have written this as an area under the curve. It is not an area under the curve. It is the squared area under the curve. So you try to understand. You don't get it as an area. To substitute here, I am just substituting. I am just using this words, terms. So area should be equal to im square divided by 2 into, it will be what? Pi. That's all. So we have found this value. And now what we need to do? We have to divide it by the total length. What is the total length? The total length will be pi, right? So I will write here area. That means this is squared area. Maybe I will write like this, because squared area, that should be equal to a squared area by total length, by total length. So that should be equal to im square divided by 2 into pi, and whole divided by pi, and that will come here, right? That will come here. So this pi. So what we can do now, we can cancel out these two terms. So finally we will get what? Finally we are getting im square divided by 2. That's all. So now this term is nothing but im square divided by 2. So what we can do? So RMS, that should be equal to square root of im square divided by 2. So what is this one? We have taken current, right? Instead of RMS, what we can write here? I can write IRMS will be equal to, see, this square and this square root. If you split this square root, then these two will be cancelled out. So you will get IM by root 2. R in other terms 0.707 IM. See, RMS value will be equal to what? Maximum value divided by root 2. And also you can write it in terms of fractional values. It will be 0.707 IM. So this is the value of RMS value. This is the value of RMS value. So now you try to understand a concept. I will write anyhow. I will write down here. So now we know, right? What is that? I RMS, which is equal to Im by root 2, or we can write it as 0.707 Im. So this is the formula now. What is Im here? Im, which is nothing but it is a maximum value. It is a maximum value. So we have already seen this. Anyhow, I try to draw the same diagram again. So if you are taking, that means I, which is equal to 5 ampere DC, 5 ampere DC, then how it looks like, this will be like this, right? So this is the value. That means this is the current and this is the time, and this is nothing but 5 amperes. So if you want to find what is the power loss, so power loss will be is equal to I square into R. Then we have already drawn a circuit, right? So if you are giving a 5 ampere source to a resistor, 5 ampere source, that is DC. So this is 5 amperes and this is 10 ohms resistor. And what is the power loss? So we have already found this. That means this will be 5 square into 10 will give you P is equal to 250 watts. So this is what we have already found. And now you see this is DC for DC. If you are taking for AC, then what I am going to write, I will be equal to 5 sine omega t or theta, anything it may be. See, this is the 5. That means this is Im. Here it will be is equal to 5. Right? Here it will be is equal to 5. Now, what you do, if you want to find what is the RMS, I have already told you, if you want to get what is the power value, you need to get what is the RMS value. RMS value. So if you want to find what is the IRMS, then IRMS will be is equal to maximum Im divided by root 2. So this will be 5 divided by root 2. Right? Then this value comes out to be IRMS will be is equal to 3.535 amperes. Right? Now what you do, you try to substitute this value. That means P by AC, right? This is P by DC. You take it as P by AC and this is a P by DC. So that this should be equal to 3.535 the whole square. That is the current value. That is the current value into 10 ohms resistor. So this value comes out to be, this value comes out to be P by AC, that will be equal to, around it will be 125 amperes. 125 amperes. See, we are not getting the same answer, right? You see, here we are getting 250 watts of power for 5 amperes of DC. For the same, what we have done, what we have taken, that means I in AC, we have taken 5 sine omega t or sine theta. Right? For that, we are getting only 125 watts of power. We are not getting it, right? We are not getting the same 250 watts power. So what we need to do? How can we get this 250 watts of power that has to be dissipated in the 10 ohms resistor, and what is the current you need to give here? It is not 5 maximum amperes. That means 5 amperes of maximum current in a AC quantity will not produce the same amount of heat energy that has been produced by the maximum value in a DC, because in DC 5 ampere will be the maximum throughout all the times. So you have to understand very clearly that 5 amperes of DC current is not the same as 5 sine omega t in a AC current. Right. My question, how will you get what is the value of current that has to be a maximum value if I want to get 250 watts of power that has to be dissipated in the resistor. Good question, right? Good question. Right. You try. You try to understand. I will. I will. I will write here. See, I will take a space here and I try to explain you things, right. So you see, I know maximum value is 5 amperes. Here IM is the 5 amperes and I need to get what is the 250 watts, what is the value of current that has to be taken to get the 250 watts of power. And you see what I need to get here. My IRMS should be 5 amperes. So if I put 5 amperes here, 5 amperes here, then 5 square, that will be 25 into 10, I will get 250 watts. So my IRMS, I know that. I know IRMS is equal to 5 amperes. So you see, if P is equal to under AC, if you put 5 IRMS into 10, then obviously what happens? PAC will give you what? 250 watts. So IRMS should be what? 5 amperes. Then if you know what is RMS value, that means you know what is the RMS value. That means 5 amperes. From that you can easily find what? IM maximum value. What is IM? From this expression, root 2 into RMS. Root 2 into RMS value, that is 5 amperes. So what this value comes out to be? This is IM, which is equal to 7.07 amperes. So you try to understand. Now I can write the I expression. I should be equal to, we know, right? IM sine omega t, or it may be theta. We know that. So I should be equal to 7.07 sine omega t, right? This has to be the value. This has to be the value to produce PAC and PAC for a 10 ohms resistor that has to be connected to a 10 ohms resistor. This current value is connected to a 10 ohms resistor. Then it will produce what? 250 watts of power dissipation. Try to understand. So in AC, IDC is equal to 5 amperes will be equivalent to, in AC, if it is a IAC, then what is that? 7.07 sine omega t. So this is why you need to understand what is RMS value. See, with a simple example, we have understood what is RMS value in AC quantity. Try to understand. We always display or say AC quantities in only RMS value. For example, in commercial usage, even in our homes, we call AC voltage that is equal to 230 volt. And what is the 230 volt? See, we cannot say AC as a 230 or 240 volts, right? It has to be 230 sin omega t or 240 sin omega t. Why we are not saying that as 230 sin omega t? What is the 230? 230, which is nothing but it is a RMS value. See, wherever you go, if you see any AC quantities, current or voltage, everything will be displayed in RMS quantities. And why we need to display it in RMS quantities? Since RMS quantity will be the equivalent to the DC quantities. So you try to understand. We have understood now. So this is the formula that you need to remember. So we will use this formula. Forever we will use this formula. IRMS should be equal to what? IM by root 2. So you learn this and you try to understand things. We will continue in the next class. We try to find what is the average value and peak crust factor, peak factors. So many AC quantities we try to find with a simple example, and with this derivation, right? We try to find what is the average value. Thank you.